Welcome back. In this video, we're going to start chapter 9 on roots and radicals. As always, when we start a chapter, it's a good idea to look ahead and see what it is that we're getting into before we get into it. So chapter 9, as I'd said, is on roots and radicals. There are a total of 8 sections in the chapter, and we're only going to go over the first 6. The other two kind of more properly belong in intermediate algebra. So we're just doing the first 6. 9.1, it says simplify and use square roots. So this chapter is about square roots. If you've heard of like cube roots or fourth roots or fifth roots, we don't deal with that here. This is just going to be square roots. So how to use square roots, how to simplify them. And then 9.2 says simplify square roots, so kind of more of the same, more involved kinds of square roots to be simplified. Section 9.3 is about adding and subtracting square roots, combining like radicals, if that rings a bell. Multiplying square roots is section 9.4. 9.5 is dividing square roots. So the first 5 sections are basically what's a square root, how do you simplify them, and then how do you add, subtract, multiply, and divide them. And then finally 9.6, we solve equations that have square roots in them. So let's get started with 9.1 on simplifying and using square roots. So first of all, let me remind you what the square of a number is. So if n squared equals m, then m is the square of n. So examples would be 25 is the square of 5, 64 is the square of 8. This allows us to think about square roots. If n squared is equal to m, then n is a square root of m. So 9 and negative 9 are square roots of 81. 1 and negative 1 are square roots of 1. 0 is the square root of 0. So one thing that you'll notice between the definitions of a square and a square root is that each number has only one square. So here I'd said 25 is the square root of 5. 64 is the square root of 8. So we've got the definite article in there if you're a language person, because it's just one, okay? Each number has just one square. However, each number has 2 square roots, which is why we have indefinite article here. 9 is a square root of 81. Negative 9 is a square root of 81. Here, for 0, I wrote 0 is the square root of 0. 0 is the one number who has only one square root, and it's just 0 itself. Every positive number has 2 square roots. 0 is its own square root. Square roots of negatives are dealt with in other courses. So if you're thinking like, well, I remember from high school, the square root of negative 16 is negative 4i or 4i or whatever it is, right? If you're thinking of something like that, we don't deal with that right here. We're just going to deal with square roots of non-negative numbers. The symbol we have is the square root sign that you've seen before. The square root sign looks like that. It looks a little bit like the long division symbol, except that it's more a hook at the end instead of what looks like a round parenthesis. But it's similar looking, kind of. The square root sign, also called the radical symbol, denotes the positive square root, sometimes also called the principal square root. The radicand, sorry, first section out of a chapter always has a lot of words, new words, definitions, and stuff. Anyways, the radicand is under the square root symbol, whatever you're taking the square root of, you could say. That is the radicand. So examples of how this is used, we'd say the square root of 16 is 4. The square root of 100 is 10. Okay, here are a couple that we can try. So negative, the square root of 49 would be negative, and then the square root of 49 is 7. Okay, the square root of 121 is 11. Why? Because in the first case, 7 squared was 49. In the second case, 11 squared is 121. For the square root of negative 36, now it's enough to just say not a real number. Okay, negative, the square root of 36. Notice here these negative is on the outside of the root symbol, so we'll just carry it forward. The square root of 36 is 6. Okay, and again, that's because 6 squared is equal to 36. An important thing to remember when you're calculating square roots is that once you've found the square root, you don't write the square root sign again. right? The square root of, let's say, 25 is equal to 5. You would not write the square root of 25 is equal to the square root of 5. Sometimes people have this desire to write the square root symbol on top of the 5 also, but you don't. The square root of 25 is just 5. The square root of 25 is not the square root of 5. So let's continue with simplifying some more roots. So here we want to simplify the square root of 25 plus the square root of 144. So doing a square root kind of has the same precedence as raising a number to a power, so it would need to happen before addition. So the square root of 25 would be 5, and the square root of 144 is going to be 12. So 5 plus 12, 17. Okay, and that's it. All right, next we have two separate questions. We have this that are related, as you'll see. The square root of 9 plus the square root of 16. The square root of 9 plus the square root of 16. The square root of 9 is 3. The square root of 16 is 4. Adding those together, 3 plus 4 gives 7. The square root of 9 plus 16, on the other hand, is going to be the square root of, well, 9 plus 16 is 25. And the square root of 25 is 5. So you'll notice here 5 and 7 are not the same, of course, right? So you can't, what this example illustrates in general, is that the square root of a plus b is not in general the same as the square root of a plus the square root of b. You can't just kind of break up a radical across an addition sign. Okay, next up, we want to look at estimating square roots. We're able to find the square root of perfect squares. So the square root of 100 is 10. The square root of 256 is 16. You can check that. The square root of 49 is 7, and so on. But other numbers, numbers that are not perfect squares, have irrational square roots. So we can, however, estimate them. So if we wanted to know the square root of 20, well, let's think about that for a minute. So we know that 20 is smaller than 25, but is bigger than 16. How I picked out the 16 and the 25 is those are the next higher and lower perfect squares relative to 20. So 16, 20, 25, 16 and 25 are perfect squares. 25 is between 20 is between 16 and 25. There's a little detail here that makes this true about the square root relationship that we won't go into. But for now, you can just know that if the 20 here between two perfect squares, then it must be true that the square root of 16, which is 4, has to be smaller than the square root of 20, smaller than the square root of 25, which is 5. So the square root of 20 is between 4 and 5. Sorry about that. Zoom crashed on me once again. So using that example as a model, take a minute and estimate the square root of 84 between two whole numbers. Okay, so 84, I need to think about perfect squares that are nearby. I know 84 is a little bigger than 81, and the square root of 81 is 9. And 84 is the next higher square root, or perfect square, is 100. So that will tell us that the square root of 81 is less than the square root of 84, which is less than the square root of 100. So that says that the square root of 84 would be bigger than 9 and less than 10. Okay. You can use a calculator to find square roots. How you do this depends on the kind of calculator you have, so I can't really help you with that. But let's try. 84, we want the square root of 84. Now we know that it should be between 9 and 10, but it says to 4 decimal places. So that sounds like 9.1652. I've rounded there to that 4th decimal place. Make sure if you're doing this on paper or some sort of computer assignment that you follow the directions about how many decimal places to give, because if you don't, it can be marked wrong. So be careful there. Okay, the next thing we want to look at is simplifying expressions containing square roots. For the square root of 16x squared, we want to find an expression whose square is 16x squared. So thinking that through a little bit, I know that 4 squared would give 16, and x squared is x squared. So 4x squared is 4x squared, 16x squared. So then we can write the square root of 16x squared is 4x. Taking the square root kind of undoes the action of a uh, square. Throughout this chapter, all the videos that we'll be producing, variables inside of the square root symbol, we're going to assume that's non-negative. So if you're looking at that once again based on your past experience and saying, well, don't you need like an absolute value on the x because the x needs to be assured to be positive? Yes, technically you do, but to keep our lives easier, this being a beginning algebra, we're not going to worry about the absolute value until we do intermediate algebra. So for now, we're just going to assume x is good and non-negative, so we don't need to worry about that. Okay, so we can not have to write 4x with the restriction that x is greater than or equal to 0. Okay, we just have a couple of simplifications to do, and then we are all done. So let's try some. So here we want the square root of x to the 6th power. So the thinking is that I want something that squares to be x to the 6th power. And thinking about our exponent rules, I know that x cubed will work. So the square root of x to the 6th will be x. Okay, using that one as a model, take a minute and find out the square root of y to the 12th power. Okay, so once again here we want something where when I square it, we'll get y to the 12th power. And thinking that through, we should get an exponent that's half as large. And so we'll get y to the 6th power. Okay, the next couple have combinations of numbers and variables. The square root of 64x squared. We need something that will square to be 64x squared. Okay, thinking that through a little bit, that sounds like 8x. 8x is the principal square root of 64x squared. Here we've got a negative, but don't worry, it's on the outside of the square root sign, so that's okay. The square root of 121 is 11. The square root of p squared is p. Okay, the next one has 2 variables in it, but that's okay. We're looking for something that when squared will give 100, a squared, b squared. The part about the 100, that will be 10. 10 squared is 100. And then we'll need AB. 10 AB is going to be the square root of 100 a squared b squared. Okay, 49x to the 30th power. Here again, we're looking for something that we can square and get 49x to the 30th. 7 is the principal square root of 49. And then for x to the 30th, we need something where the exponent is half as large, so that will be x to the 15th. So 7x to the 15th is our answer for the square root of 49x to the 30th. Okay, last example, and we are all done. Here we're looking for something that squares to be 169, x to the 10th, y to the 14th. 169, that one may not be too familiar to you. You could use a calculator or a table or trial and error on this. For these kinds of problems, for now at least, they're perfect squares throughout the assignments for this section. So this one, 169, that's the square of 13. X to the 10th, that will be x to the 5th when we take the square root. And y to the 14th power, that will be y 7th. So our final answer for this one, 13x to the 5th power, y to the 7th power. All right, that takes us to the end of this video and the end of section 9.1. Let me know if you have any questions, and have a great day.